this is the solutions to the even-numbered problems in the Chapter 13 review. So we'll start with number 12. Number 12 asks which measure of central tendency best represents the data. And in this one, because there's no extreme values and there's no repeated numbers, the mean would be the one that fits it the best. And it also asks you to find that measure of central tendency. So we would add all of the numbers together, and since there are 6 of them, we would divide by 6, and the mean you should come up with 135.5. All right, the next one is number 18. Number 18 asks to find the measures of variation and any outliers of a set of data. So the easy one to find would be the range to start with, and then to do that we just subtract the biggest one minus the smallest. So that's 10 minus 5, which is 5. And then in order to find any of the other ones, we need these numbers in order. So 5, 6, 7, 8, and 10. The median is the middle, so the median is 7. The lower quartile, the median splits the bottom part of the data into just these two numbers, so the lower quartile is the average of these two, or 5.5. And then the upper quartile is the average of these two, which would be 9. So now to find the interquartile range, we just subtract the upper quartile minus the lower quartile to get 3.5. So those are our two measures of variation. And now to find if there are any outliers, we multiply 1.5 times the interquartile range, which is 3.5, to get 5.25. And then we want to take this number and add it to the median and subtract it from the median to figure out what the acceptable range is for a number to not be an outlier. So we'll take 7 minus 5.25, and we get 1.75, and then 7 plus 5.25 to get 12.25. And if we look at our data values, there's nothing that's lower than 1.75, and there's nothing bigger than 12.25. So this means there are no outliers. Okay, so here's the range, the interquartile range, and no outliers. All right, we'll go on to number 24. Number 24 tells you that you have 2 blue marbles, 5 red marbles, and 8 green marbles. 1 marble is selected at random. Find the probability of a blue or a green. Well, there are 2 blue marbles and 8 green, so that's 10 that are either blue or green out of 2 plus 5 plus 8, or 15 total. And when we reduce this, this reduces to 2/3. Okay, the next one is number 30. Number 30 asks for the number of possible outcomes if customers can choose vanilla or chocolate ice cream and strawberry chocolate or caramel topping. Okay, so they're choosing ice cream. They have 2 choices. And toppings, they have 3 choices. And the fundamental counting principle says that we just multiply these two numbers. So 2 times 3 is 6. The next one's number 36. This one asks, how many different ways can you select 8 prizes out of 20 choices? Remember with this, the first thing to figure out is if order matters or not. And if you're choosing prizes, it doesn't matter which one you choose first or second or third. So order doesn't matter, so we want a combination. We're choosing from 20 things, we're choosing 8 of them. So this is, if we have 20 choices for the first one, and then 19 for the second, 18 for the third, 17 for the fourth, 16 for the fifth, 15 for the sixth, 14 for the seventh, and 13 choices for the eighth. But then because it's a combination, we've counted all of those permutations that are essentially the same grouping. So we divide by the number of ways to reorder those 8 items, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we get some pretty large numbers here. This is 5,079,110,400 over 40,320. And when we divide this, we get a final answer of 125,970. That's a lot of outcomes. All right, the last one, number 42. 42 says a box contains 8 red markers, 5 green markers, and 5 white markers. Once a marker is pulled from the box, it is not replaced. We want to find the probability of choosing white and then white again. Okay, so the first time, the probability of choosing white, there are 5 white markers to choose from out of 8 plus 5 plus 5, 18 total. Well, now assuming that a white was chosen, there's now only 17 markers left to choose from, and because a white was chosen out of these 5, there's now only 4 remaining that are white. And because we want both of these to happen, we multiply the probabilities. So 5 times 4 is 20. 18 times 70 is 306. And when we reduce this, it reduces down to 10 over 153.